Hey everyone, it's time for us to start making routing more real. We're going to start looking at what's involved in building medium-sized networks. We talked about small networks, individual small organizations that are connected to the internet. But now what we're going to do is we're going to start exploring the nuances and the values that we need to recognize as being important or unimportant when it comes to sending information through larger infrastructures. Not huge, but definitely medium-sized business style networks. Now that's going to make us first have to understand the fact that we've mentioned the fact that when we have switches, we have this idea of being able to send information from broadcast domains, and typically we use a router for that process. So what I want to do is I want to highlight some of the nuances behind routing between VLANs, something referred to as inter-VLAN routing. Now in the confines of inter-VLAN routing, really and truly what we're going to have here is this notion of a VLAN, which is nothing but a virtual LAN. Cisco came up with a concept. It's a proprietary solution that has been adopted over the years. But what it does is it allows me to create things like an HR VLAN and, say for instance, a management VLAN or any other style VLAN. And what I can do is I'm going to have these connected, and what's going to happen is they're going to be broke up into separate domains. But if I want to be able to communicate, say between this device A, B, C, and D. So if I want to communicate between A and C, I need a way to get traffic through there. And right now I don't have that. I don't have that because I do not have any type of routing capacity configured into this infrastructure, because this is just a normal switch. So what I need to work at and what I need to figure out is how do I actually get information to move across that infrastructure. And I'm going to have to use some type of routing method. Now we have a number of options. In fact, it boils down to three principal or primary options. Bear with me one second, I lost my pen. Very sorry about that. So, in the grand scheme of things, we have three ways to implement this. The first method is going to be, we want to put a router, an actual physical router, between the separate VLANs. The second way would be to do what's referred to as a router with a trunk. So when we look at that, that's going to be pretty handy, and also we can enable layer 3 routing on some of our devices, provided that they're going to be capable of supporting it. So when we recognize how we're going to deploy this, we want to entertain each of these individual options. And the first one we're going to look at is the idea of being able to put a router between the separate VLANs. Now notice what I've done in this scenario is I have a connection on VLAN 10, and what I'm doing is I'm actually connecting it to a router where each of these interfaces are actually still part of VLAN 10. Then what I can do is I can come up here and I'm going to do a similar connection where I'm going to have VLAN 20 and a dedicated interface to VLAN 20 on FAO 01 going up to my router. So now this router can actually do what routers do. It's going to ensure that I have the capability of being able to move information between these two broadcast domains. VLAN 10 and VLAN 20. Each of these have their own networks. And I can send information between them now because the information is going to go up this link to the router and then get sent down. And now I have an avenue with regard to getting information from point A to point B. Now another option that I have here is going to be router with a trunk link. Now what this is sometimes referred to in the vernacular is called router on a stick. Now, a router on a stick configuration means I'm going to be running a trunk. A trunk is a special circuit. A trunk is a special circuit that allows me to carry traffic for multiple VLANs on one link. Now, in order to be able to do this, what I'm going to have to do is I'm going to have to make a special configuration on the router and a special configuration on the switch. These configurations on the router are going to include creating something called a sub-interface. So I'm going to create a sub-interface and I'm going to give it a value like .20 or .10. So all I'm doing is I'm actually saying this .10 is going to be part of this VLAN and this .20 is going to be part of this one. Keep in mind that this value right here in iOS could be anything. I could say 200 and 100. It's just when it comes to actually setting this up on a router on a stick style scenario, what we're going to want to do is we're going to make certain that it's at least intuitive. So I would normally use for my sub interface the value that I'm going to have on my device with regard to what VLAN I'm going to be participating in. And this is going to require me to actually run this as an encapsulated link. So what's going to happen is I'm going to use encapsulation to make certain on this trunk that I'm going to keep traffic separate and isolated from each other. That's going to be one of the more important components that we need to recognize. Now, the other part of this is that we need to bear in mind that our other option is going to be to enable layer 3 routing on our switch. What we see here in this illustration is a layer 3 capable switch. This layer 3 capable switch can run a routing protocol, or it could just operate as a router. All I got to do is go into the system and say that I want to enable IP unicast routing. The moment I do that, if it's a layer 3 capable switch, it's going to immediately take the links that we have between them. It's going to build the connected interfaces. So we're going to have connected for 10.1.10.0/24, and it's going to have connected for 10.1.20.0.24, and these are going to be what's going to exist in the routing table, and it's going to give me ample information to get information from point A to point B via this layer 3 capable switch in order to be able to do this idea of routing. Now when we look at this and we start really stepping into what's going on here, what we actually see is the fact that when we set up our configuration, the hardest is going to be this idea of doing a router with a trunk, or this router on a stick scenario. Router on a stick. Now the router on a stick config requires me to configure a trunk. But it also requires me to configure sub-interfaces. So notice I have gigabit 00. So what I'll do is I'll create gigabit 0010 and I'll create gigabit 0020 in these scenarios. And all I'm doing is I'm just saying these are numbers. They're not necessarily corresponding to anything. But what I'm going to do is I'm going to tell the system that I want to use encapsulation for this VLAN, VLAN 10. Encapsulation for this VLAN, VLAN 20. I'm going to give it an IP address out of that range, and then what I'm going to do is I'm going to reap the benefit of me again having those two connected interfaces across a trunk. Now when we start sending information, that information is going to travel from VLAN 10 up to the router. The router is then going to hairpin it and send it back down by allowing me to route between my two VLANs. And that's really and truly all a router on a stick does. The router on a stick configuration is pretty straightforward and easy to configure, but of the ones that we have to work with, it's going to be possibly the most problematic. Now the other thing that I need to do is I need to assign the interfaces. So this needs to know that it's VLAN 10. This one needs to know that it's VLAN 20. The way that I do that is I go under my configuration for each of those interfaces and I tell it which switch port VLAN it's participating in. So switch port access VLAN 10, switch port access VLAN 100 on this interface and on this interface, which should be up here, FA03. So now I've built my trunk, I've built my individual links, and what I recognize here is that my trunk has the capability of carrying traffic for both VLAN 10 and VLAN 20 through this concept called encapsulation. So again, as I send information up, it's going to go across, it's going to come back through, and it's going to be able to get to its actual destination. So again, this is going to be one of those processes where we want to make certain that we understand how we have the system configured, and we need to verify things. So first of all, on the router, notice I have the capability of specifying show VLANs. So I can look at any of the VLANs that I have configured, and what we're going to see is we're going to have VLAN 20 and VLAN 10 based on the fact that we're running 802.1q encapsulation. 802.1 encapsulation is just one flavor of the idea of trunking. We have the industry standard, which is 802.1q, and we have Cisco proprietary, which is ISL. ISL, inter-switch link encapsulation, isn't really as much encapsulation. Well, it is encapsulation where trunking is, where .1q is actually inserting a tag or a flag into the header. when we run with ISL is Cisco proprietary, so it's gradually going the way of the dodo. It's not going to be one of those technologies that we're going to encounter in a real, live, functioning network that's going to be considered to be modern by any stretch of the imagination. Now the next part of this is like I said, on the router we can do the show VLANs, and on the switch we can also take a look at our show VLAN configurations. So again, just looking at this from a 30,000-foot view, we have the three different methods of being able to get information between VLANs. We have the router on a stick. We have dual connections to a router where we have actual physical connections involved, where each connection is going to carry one VLAN up to the router. The router is going to make the decision. In the router on the stick scenario, we need to have a trunk because we want to rely on that trunk to carry multiple VLANs up to the router. And we can have any number of VLANs that we're going to provide services or routing services for. Another part of this equation is also keep in mind that we have the capability of supporting layer 3 routing on our switches themselves. So when we look at it, we have lots of options with regard to how we're going to have things deployed, and that's going to wrap up our conversations at this particular point, and I'll see you guys in the next lesson. Bye-bye.